Hello, welcome back to the session on Introduction to Networking Devices. Today we are going to discuss about the various networking devices that help the network to communicate. In the last few sessions we have learned about the various components of a network and the different types of networks that are available and how to set them up. But today we are going to discuss about the various functions that these networking devices provide to ensure that there is communication, whether it is internet or intranet. So let us look at what we have for today. What are the topics that we are going to discuss today? So today we are going to discuss about these topics, that is network interface card and its functions, the different types of networking cables and its functions, and switches, the network switches, their functions, routers and their functions, and access point and their functions. These are the various networking devices that help the communication between the source and the destination, between the user and the server. Like today we access a lot of websites. So these websites are accessible with the help of these networking devices. So let us now start with the first component, that is network interface card. So the network interface card is an interface between the device, that is it could be a PC or a server or a printer or a smartphone or a tab, and the network. So this network interface is also called by a different name, that is it is also called LAN port, LAN card, Ethernet port, Ethernet card, or the other names that we give to this network interface, where each network interface contains a unique address. Means every computer, every network device has a unique address, and this address is called as MAC address, also stands for Media Access Control. MAC stands for Media Access Control, and this MAC address is of 48 bits. So here we should know that bits looks at like binary format. 48 bits represents 48 consisting of values of zeros and ones, 48 zeros and ones, and this is very difficult to remember, and hence this 48 bit address is converted into hexadecimal notation. It is represented in hexadecimal notation. So a MAC address is converted from the binary format to hexadecimal format, and this MAC address is also given another name called physical address, or also called hardware address. So this physical address and hardware address are given the names because this is an address which is permanent, and this address cannot be changed. This MAC address comes along with the device. So when you buy a laptop or a computer or a smartphone or a tablet, these contains the MAC address inbuilt, and this cannot be changed. So network interface card is an important component of the PC, of the server or the smartphone, and it has a unique address called as MAC address, and this MAC address is of length 48 bits. So how do we know that our computer has a MAC address? We have various options to find out how to find the MAC address of a device. Let us look at that option, where it is like this is a computer. In this computer you can see here there is a LAN cable or Ethernet cable connected to this port. So this is the network interface card of that particular computer. On the right hand side we have another computer, and you can see the RJ45 port, and this is called as network interface card. So network interface card is available for every network device. What we see here is for the physical network interface card. For smartphones and tablets and other devices, there will be wireless network interface card. Wireless network interface cards available for laptops, for smartphones as well as tablet devices. So, to get to know the MAC address of a Windows operating system, if your computer is having Windows operating system, then to find out the MAC address of the computer or the network interface, we have a command called get MAC. So, by executing this command at the command prompt, we can get to see the output and we can know the MAC address of the device. Alternatively, we have another command available with the help of ipconfig/all. So, with this command also we can get to see the output. These are the two commands that we use in the Windows operating system, and if you have a Linux or Unix operating system, then we have another command that in the operating system prompt give the command ifconfig. So, these are the various commands that we can execute on Windows and Unix or Linux operating systems to find out the MAC address. So, we have an example that is available here with us, that is the MAC address of the local computer. So, you can see this is a Windows operating system, and in the Windows operating system we are executing this command called get MAC. So, with the help of this get MAC, we could see this is the IP MAC address of the device. You can see there is mention of called physical address. Physical address means MAC address, is also called as hardware address, and you can see the address is represented in hexadecimal notation. So, in hexadecimal notation, the values are ranging from 0 to 9 and A to F. So, let us look at the conversion of the MAC addresses in the form of hexadecimal notation. So, all hexadecimal addresses starts from 0 to 9 and A to F. So, the representation is 10 0 to 9 represents the same values, and 10 in decimal equals to A in hexadecimal, 11 is hexadecimal value B, 12 is C, 13 is D, and 14 is E, and 15 is F. So, this is the representation in hexadecimal format. These are the hexadecimal values and its equivalent decimal values on the left hand side. So, the value of 15 equals to F. So, if you look at this particular MAC address on the left hand side, A0 1D 48 C1 7614, that is the MAC address of one of the network interface cards. Since we can see two different MAC addresses, it represents that this local computer has two network interface cards. So, maybe one of them is a physical Ethernet port, other one is a wireless Ethernet port. So, we can also use another command alternatively to find out what we have for our local computer. So, I give the command ipconfig, and then since this output is going to be lengthy, I pipe to more, means we can see one screen at a time, ipconfig/more. So, you can see the various interfaces available on your computer. Wireless LAN adapter is available, and also the Ethernet adapter. This is the physical port. Ethernet adapter is the physical port. Okay. And we have another command which is ipconfig/all and more. This will give the MAC address of the interface as well. So, you can see here in this output we have the wireless interface having this particular MAC address. We can also compare from the MAC address that we have. So, you can see the second MAC address which is 48-5A-B6-55-02-61. So, we can see that that particular MAC address here, you can see here, this is the MAC address which was displayed on the output of get MAC. Okay. And alternatively, we also have the Ethernet interface, the physical port on the computer, physical port, Ethernet port, and this is the first MAC address, A0 1D 48 C1 7614. So we can see all the physical addresses from the output of the command IP config /all. So these are the important commands to verify the MAC address of the local computer on Windows. So on the Linux operating system, we have seen the command we must be using ifconfig. So this command will provide the MAC address of the computer in the Linux or Unix operating system. So what do we learn from this discussion is that every network device must have a network interface. Without network interface, the device cannot send and receive data. So this is one of the most important component for the devices to send and receive data. So we can see the examples here. Every PC, laptop, every server, every router, every switch, every access point, every firewall, every smartphone and a tablet, and also smartwatches. So everything that can send and receive data should have the network interface, either the physical network interface or the wireless network interface, as we have seen just now in this example. You can see both. This is a wireless adapter having the MAC address, and this is a physical Ethernet port having the MAC address. So each and every type of interface will have a MAC address. Only then the device is capable of sending and receiving the data. So in the next discussion, we have, this is the MAC address, which is a 48-bit address, and in this 48-bit address we can see the first half of this particular MAC address, which is like 24 bits. The first half of the MAC address is given a special name called OUI, which stands for Organizational Unique Identifier. Organizational Unique Identifier. The first 24 bits of the MAC address is called as OUI, and it is also called as manufacturer ID or vendor ID, because those who manufacture the network interface cards, they will be given a code. The first 24 bits of the MAC address are called as vendor ID, and the technical name is called OUI, which is Organizational Unique Identifier. And the last 24 bits are basically a sequence number allocated by the vendor for each network device. And this OUI is something which they have to buy from the IEEE body, so that every device on this planet, every network device on this planet has to have a unique MAC address. So MAC addresses are so important, and it is available for each and every network interface card. So this is the discussion about the MAC addresses, which are available for every network interface and for every network device. In the next discussion, we have the cables. Cables are also an important part of networking. Without cables, we will not be able to connect physically computers to the network, or servers to the network, or printers to the network. So cables come in two different categories, that is twisted pair cables, which are very widely used across the globe for setting up the local area networks, and we also have another type of cable called fiber optic cable. So cables are required to connect the end devices like PCs, servers, printers, etc. to the network with the help of these networking devices called switches, routers, and access points. So if you look at this twisted pair cable is further divided into two different types of twisted pair cables called unshielded twisted pair called UTP and shielded twisted pair called STP. So the twisted pair has again further two different types called UTP and STP. So, what is the difference between the UTP and STP? So, physically the look of the cable is the same and the functionality is also the same, and the amount of bandwidth that is supported on this type of cable is also the same. But the key difference is that the term shielded provides additional protection from the electromagnetic radiation. So, in most organizations they use UTP because they do not have any electromagnetic radiation in their organizations. So, very few organizations have this electromagnetic radiation, and in such type of networks they use the shielded twisted pair cable. So, in this picture we can see the first two pictures are related with the UTP cable, unshielded twisted pair cable. They are in different categories. You can see here category 5 cable supports maximum bandwidth of 100 Mbps. The UTP cable Cat 5 supports maximum of 100 Mbps, whereas Cat 6 cable is advanced and it provides up to 1 Gbps. It provides up to 1 Gbps. And on the extreme right we have the STP cable, shielded twisted pair cable. And if you observe the first two pictures and then the third picture, there is some additional cover for each pair of cable. In the case of the first two, we do not have any additional special coat. A silver color coating is not available for the first two cables because they are unshielded twisted pair cables. And the third one, we have a special shielding. This is providing the additional protection from the electromagnetic radiations. Apart from this, you can see there are 4 pairs of cable in each of them, whether it is Cat 5 or Cat 6 or STP Cat 6, they still have only 4 pairs of cable. So, 4 pairs of cable represents 8 wires. And remember, for data transfer, the computers, the servers, the laptop, when connected with this physical cable, they use only 4 wires, which means 2 pairs. So, out of the 4 pairs that are available in the network, there are only 2 pairs that are used. So, we have these cables which provide connectivity between the network devices like PCs, servers, printers, and to the networking devices like switches. The next page we have the various speeds or the types of cables that are available. We are only representing it is category cable, but we are not mentioning whether it is UTP or STP because they are available in both categories. Cat 5 cable is available both in UTP and STP and offers a maximum bandwidth of 100 Mbps, and Cat 5e stands for enhanced, and it has a capability to support 500 Mbps of bandwidth on one cable. And the Cat 6 cable provides up to 1000 Mbps, or we call it as 1 Gbps. So, all these 3 cables are available both in the unshielded twisted format as well as shielded twisted format. But if you look at, they have a limitation, the distance between the computer and the switch, the distance between the server and the switch, the distance between the printer, network printer and the switch cannot exceed 100 meters. So, when we use this twisted pair cable, there is a limitation of distance, and the maximum distance supported is 100 meters. So, let us suppose we have this. So, let us take one computer here. And another computer, and we want to connect these 2 computers to the switch. We want to connect these 2 computers to the switch, and this is PC1 and this is PC2. So, in order to physically connect these 2 computers to the network, we require a cable. So, this is the cable we are discussing about, UTP cable or STP cable. and it is Cat 5 cable or Cat 6 cable. So, this length cannot exceed more than 100 meters. The maximum distance is 100 meters. The maximum distance between the computer and the switch is 100 meters. It cannot be greater than that. So, this is the limitation of the twisted pair cable, both UTP and STP. So, the next discussion is about the second type of cable called fiber optic cable. So, this fiber optic cable provides higher bandwidth and as well as long distance. This provides higher bandwidth as well as long distance. You can see the main advantage of fiber optic cable is higher bandwidth and supports long distances compared with the twisted pair cable. Suppose we have to connect two buildings which are more than 100 meters away, or the distance between two buildings is more than 100 meters, and we want to connect the local area network in building 1 to the local area network in building 2. So, the UTP cable cannot provide the support because they have a limitation of maximum 100 meters. And this fiber optic cables are also available in two types. They are single mode fiber and multi-mode fiber. Single mode fiber is used for short distances, preferably less than 5 kilometers. Less than 5 kilometers. Then we have, the single mode cable is for long distance and multi-mode is for the short distances. If you want to run the cable from, let us say, Hyderabad to Delhi or from Hyderabad to Chennai, we use it for single mode purposes. So, this is the fiber optic cable widely used, and you can see how the fiber optic cable looks like. So, what you see on the right hand side and the left hand side, we can map them. The outer jacket is basically the one which we see in the black color here. This is the outer jacket of the fiber cable. So, and inside you can see the second layer, and this second layer is what we say strength member, which means it is providing very strong this connectivity. Some kind of steel is available there to provide strength to the cable. And then the third layer we have coating. So, this is the colored ones that you see here. This is the coating, and then there is cladding, and then that is the last one you see is the fiber. We call it as core. Core is nothing but the fiber, which is basically a glass, which is very, very delicate. It is very, very delicate. So, this is how the fiber optic cable looks like, and we have seen both the twisted pair cable, how it looks like, and the fiber optic cable, how it looks like. So, normally we use the fiber optic cable for long distances, and they support, let us say for example, you want to connect from Hyderabad to Delhi. So, it is few hundreds of kilometers away. So, what we do is use this single mode fiber, and many of the single mode fibers have the capability to run up to 100 meters or beyond. There are certain specific single mode fibers which can go beyond 100 kilometers without using any repeaters. But if we have to use UTP cable, the theoretical distance is only 100 meters. So, if you want to extend beyond 100 meters, we have to use repeaters, maybe something like hubs, or there are specific devices called repeaters, or you may use switches to extend the distance beyond 100 meters. But for the fiber optic cables like single mode, it has a capability to support up to 100 meters and beyond, and then you have to have a repeater so that it can extend for another 100 kilometers. And the multi-mode is used for short distances within the campus, within the building, from one floor to another floor. We can use the multi-mode fiber, and also supports very high bandwidth. So, we have seen the network interface card, which is available for every network device, and every network device has this network interface which has a unique MAC address, which is 48 bits in length, represented in the hexadecimal notation. And to connect these networking devices to the network, we use cables, that is twisted pair cables or fiber optic cables. If the network is small within one room or within small building, we use UTP cable. And if it is to connect between buildings, or if you want to connect from your office in one city to your office in another city, then we use this fiber optic cables. So, the next discussion is about the network device called switch. So, this is a very important component in the network because it provides connectivity to all the computers and servers and network devices. This yesterday when we discussed about the OSI layers, we have discussed about the various examples, and for data link layer the example is switch. So, switch is called as layer 2 device. The network switch or LAN switch is called as layer 2 device because it works at the data link layer. And we call this as intelligent device because it builds and maintains MAC address table. Every switch internally builds and maintains MAC address table. So, we use the word it builds because by default the switch does not have any information in the MAC address table. The switch does not have any information in the MAC address table, it is empty. So, as and when the users exchange data between the computers, let us suppose in this diagram we have a switch and these are the computers. So, this switch maintains a MAC address table. I will show you later on how it will look like and what information is present in this table. So, let us say this is the MAC address table. This MAC address table is empty, does not have any information. As when the users start sending the data, it will learn the MAC addresses and fill this table. As and when the users send data, the switch will learn the MAC addresses. So, I will show you how that happens in a little while. So, typically a switch is a LAN device to connect all the components or all the network devices in the LAN. So, the switch allows multiple network devices like PC, laptop, servers, printers, IP phones, IP cameras to be connected to the network with the help of this cables, UTP cables or STP cables or fiber optic cables. So, switches are important devices because they concentrate multiple devices and facilitate communication within the LAN. So, there are different switches providing different speeds or bandwidth. So, there are switches which have 100 Mbps ports, there are switches which have gigabit ports, there are switches which have 10 gigabit ports, and they come in different configurations. Like any switch that is available, they may be there are some smaller switches which have 8 ports also, 16 ports and 16 Ethernet ports on one switch, or 24 ports or 48 ports. These are the commonly used types, and there are for some large organizations the switch manufacturers have modular switches which can provide more than 100 or 150, 200 ports on one single switch. But standard switches come in 24 port and 48 port configurations. And you can see most or majority of the switches that are available in the market, they come with 100 Mbps ports, and there may be few gigabit ports that allows higher bandwidth to communicate from one switch to another switch. So, what we mean by this is, suppose in this diagram we have one switch already, and then we want to have another switch because we have more number of computers, we want to have another switch. So, to connect between these two switches, we need a gigabit port. So, this port which is represented here, this particular port, on this switch as well as and this particular port on this switch connecting between the two. Okay. It is this link is a gigabit link. This particular port is a gigabit port. This port on the switch is a gigabit port. This particular port is a gigabit port. This particular port is a gigabit port. So, these gigabit ports provide high bandwidth between the switches. High bandwidth between the switches. Gigabit ports are also important for the network speeds. Then they work in full duplex mode. There are two types of modes available on the switches, that is full duplex and half duplex. What does full duplex mean? Full duplex means the device can send and receive data simultaneously. The device can send and receive data simultaneously on the single port. So, this is a full duplex. There are certain devices which work in half duplex mode, which means they can either send the data or receive the data. They cannot do both simultaneously. So, full duplex provides sending and receiving data at the same time. So, we have already seen that the switch has the MAC address table, but it is empty. But as and when the users send and receive data, the switch builds the MAC address table. It will build the MAC address table only when the data is received by the switch. So, we will take an example of how the switch works, and we call this as the functions of the switch. So, here we have a switch, and this switch is connected to few computers on these corresponding ports, port number 1, port number 2, port number 3 up to 8. There are 8 ports on the switch, and there are 8 computers connected. There are 8 computers connected to this switch. And let us take an example of one of these computers sending data to another computer in the same network. So, we call this as a local area network. We call this as local area network. So, there are 8 computers connected to the 8 ports on the switch, and we want to send data from computer number 1. This is the computer number 1, and this is computer number 1, this is computer number 2, this is the source. He is sending the data, and he is sending the data to the 4th computer. This is the destination. S stands for source and D stands for destination. So, we want to send the data. So, you can see the data packet. The data packet contains the source MAC address, that source MAC address of that particular computer which is sending the data. This is the MAC address. You can see it is in hexadecimal notation. The data is sent to the 4th computer. So, the request generated by this local PC goes to the switch, and the switch, because it is an intelligent device, it opens a header and reads the source MAC address, means who sent this message to me, and then it will verify on port number 2, does port number 2 have any of the entries currently available? Is the MAC address table having any MAC address currently? No, it is all empty. All the 8 ports do not have any information. The switch MAC address table is empty by default. So, now the first packet has arrived on port number 2, and the switch is reading the source MAC address, and this source MAC address is learnt on the switch MAC table. The source MAC address is learnt on the port number 2, because we have received the data on port number 2. Now, based on this information, the switch will now look for the destination MAC address. I want to send data to this particular MAC address, and it starts looking for that particular MAC address in the MAC address table. So, you can see the switch is verifying where that particular destination is available. Can we find it? Is that particular destination MAC address currently available in the MAC address table? No, it is not. So, the switch clearly knows that the destination is not available or not known to the particular switch. So, what the switch does now is it will send this particular frame or this particular packet of information to all the ports except the port on which it received the data. So, you can see this particular device, computer 2, which actually sent the data, is a source, and the switch received the destination message, and then we have the message delivered to all the ports because the destination was not available in the MAC address table. So, all the devices will discard this message except this computer number 4, because for that particular computer the destination MAC address will match. And let us say this destination again sends message back to the second computer. The switch learns the MAC address of that particular computer in the corresponding port, and then looks for the destination, which is computer number 2, and it has that particular information, and it will forward this message only to the computer on port number 2. So, when the switch knows the destination MAC address, it will forward only to one particular port, and if it is not available, it will flood the port on all the ports except the incoming port. So, these are the functions of the switch. And next we have the router, which is a layer 3 device, very important for internet and intra-network communication. We say it allows communication between 2 or more different IP networks. So, it is called as inter-networking device, and we need or we must have this router to access internet. Without a router, we will not be able to access internet. So, functions of the router: inter-network communication, best path selection, packet switching, and packet forwarding. So, in this diagram we have 3 offices, and one computer in one of the offices is a source, and it wants to send data to this destination computer. So, when the packet is sent from the local network, the packet will be forwarded to the local router, which in turn has to select the best path from the available paths and forward the packet to this destination. So, that is a function of the router, but more in detail about the internal functioning of the router we will be discussing in the next sessions. So, this is the importance of the router to facilitate communication between different networks. So, we have today discussed about the various components, networking devices, their functions, which are very essential and important. So, with the help of these networking devices, that is switch, router, and every computer having the network interface card, as well as connecting these network devices to this via the cables through UTP or through STP. So, we will be concluding this session where we have learnt about the various networking devices, their functions, and in the next session we will be detailedly discussing about the functions of the router and the way the router works, the way the router builds the routing table, the various methods of routing, and most importantly these connectivity and devices have another important feature to be included, that is the IP address, the Internet Protocol address. So, in the next session we will be discussing about the IP address, the functions of the IP, the different classes of IP, the different versions of IP address, that is IP version 4 and IP version 6, and also about the router's functionality. So, with the sessions that we have discussed so far about networking basics, networking advanced, and today's session about introduction to networking devices, we get a clear picture of what we have learned so far. In this picture you can see all the components that we have learnt today. So, you can see the switch, we can see the router, we can see the cables that we have discussed, we can see the components, the server, and they are all connected to the internet. So, this is an overview of the various networking devices and cables and connectivity, and all these require an IP address so that they can communicate. So, IP address plays a very important role in the data communication, without IP address they will not be able to communicate. So, today's discussion about MAC address network interface card will be continued in the next session, where we will be learning about the IP address and its advantages and how the IP address helps the data communication from one network to another network. So, we have overview of the various components, networking components, network devices, their functionality. All this will be helpful to find out the way the networking works.